Welcome to Brain Vision.
Firstly, for this problem, we'll calculate the kinetic energy of the hammer just before it strikes the nail. And the kinetic energy of the hammer is a half mv squared, where m is the mass of the hammer and v is the speed of the hammer before it hits the nail. And we know these values. So this is a half into the mass of the hammer, which is 1.8 kg, multiplied by the square of its speed before it strikes the nail, which is 7.8 meters per second, and that's squared. And this gives us a kinetic energy of 54.8 joules. But remember, each strike of the hammer only transfers 60% of this. 0.6 of this kinetic energy gets transferred to the nail. And this energy is 0.6 times 54.8, which is 32.9 joules. So that's the energy that's transferred to the nail. So with 10 strikes, 10 into 32.9 is simply 329 joules. So the total energy transferred to the nail from the hammer is 329 joules. Now, if we equate this kinetic energy to the heat energy transferred to the nail, then we know we can use the equation Q is equal to mc delta T. So the temperature change of the nail is due to the energy it receives after being struck by the hammer. So if we rearrange this equation, we can solve for this temperature change, delta T. Delta T is equal to the energy transferred to the nail divided by the mass of the nail times the specific heat capacity for aluminium in this case. And again, all these values are known. So the total energy transferred to the nail we saw is 329 joules with 10 strikes. The mass of the nail is 8 times 10 to the minus 3 kg. And the specific heat capacity for aluminium from our tables is 0.91 times 10 to the power 3 joule per kg Kelvin. And if we do this calculation, we see the temperature change of the nail after being struck 10 times is 45.2 Celsius degrees.